Okay. This is a rational function that we're going to look at. And the rational function consists of a linear term in the numerator, a linear term in the denominator. So I'm going to say the form of this function is linear times linear divided by linear. It's just one example. You can do, put any numbers in here you want. You can put a coefficient in front of x, whatever. Okay, so, excuse me. Okay, the numerator of this function is 0. Now we've seen most of this. The numerator is 0 if x is negative 4 or x equals 2. That's very easy to understand, and we've done this before. And the denominator is 0 if x equals negative 9. Okay? Now, if the numerator is 0, it doesn't matter what the denominator is unless it happens to be 0, in which case x wouldn't be in the domain of the function. But if the numerator is 0 and the denominator isn't 0, which is the case for x equals negative 4 and plus 2, then the y value is 0. So we're going to have zeros of the function at those points. Now, over here is a graph where I've depicted the three values of x that make the linear factor 0. And at y equals negative 4 and y equals 2, we have zeros. Now let's think about the denominator. The denominator is 0 if x equals negative 9, but as I implied just a minute ago, division by 0 is undefined, so that x equals negative 9 is not a legal value. So here we have it. So there's no point on the graph that has x-coordinate negative 9. And since all the points in the graph with x-coordinate negative 9 lie above and below negative 9 on the x-axis, this dotted line represents a bunch of forbidden points. The graph can't pass through this line. The function is not defined on this vertical line. Okay, the denominator is small if x is close to negative 9. So the closer x gets to negative 9, x starts there and moves over closer and closer to negative 9, the denominator gets smaller and smaller, which means that the value of the function gets bigger and bigger. That might be a big positive or a big negative, but it's going to get big because when you divide by a small number, whatever number you get in the numerator, it's going to go into it more and more times. Now if you approach from one side of negative 9, if you approach from the right, x plus 9 will be positive. If you approach negative 9 from the left, x plus 9 will be negative. You're going to use that. Okay, now important point, again, there's no limit to how small the denominator can get as x approaches negative 9. So there's no limit to how big y can get as x approaches negative 9. So if y is positive as you approach negative 9 from the right, and we'll see whether it is or not. If it's positive as you approach negative 9 from this side, it's going to go into really big positive numbers and you're going to get a positive asymptote. And if you approach from this side and the numbers are negative, you're going to get really big negative numbers and you're going to have an asymptote on this side. So we're going to see how that works out. Okay. So another thing is y can only change its sign if one of these terms changes its sign. And this term only changes its sign if x goes from less than 4 to greater than 4, which means it only changes sign when x is 4. In other words, well, I think we got that idea. And this only changes sign when x goes from one side of 2 to the other. This only changes sign when x goes from one side of 9 to the other. Okay? Doesn't mean it necessarily has to change sign, but that's the only place where it can. And in this case, it will change sign at each of those values. Okay, so Another thing we note is if x is very big number, x minus 2 and x plus 9 are practically the same. 1,000,002, or 999,998, and 1,000,009, which is what you get if x is 1,000,000. Well, x is only 2 less than 1,000,000, or it's only 9 bigger than 1,000,000. Not much different than 1,000,000. So these numbers are very close to each other. So this quotient is very close to 1. And it follows then that y, which is equal to x plus 4 times x minus 2 over x plus 9. And you could group that, you can see you've got the x minus 2 and the x plus 9 there. That much of it's close to 1, so the rest of it is just close to x plus, well, the value of y is close to x plus 4, because y is close to x plus 4 times 1. Okay? Now this gives us another clue. If y is very close to x plus 4, then we can graph x plus 4. So let's just say 4 is right here, and that gives a slope right at about 45 degrees. So the line at y equals x plus 4 will be here. So as x gets very big on that side or on this side, the graph is going to get close to this line, just because of the way the values act. Okay, well, let's put all this information together. Let's figure out if x is greater than 2. Well, if what I said about this line is true, then x greater than 2 means that the value of the function has to be positive, otherwise it couldn't get close to that line. Well, we're not going to rely on that. We could make a mistake, so let's just be sure. If x is bigger than 2, then x plus 4 and x plus 9, any number bigger than 2, if you add it to 4 and add it to 9, it's going to be positive. And any number bigger than 2, if you subtract 2, you're going to get a positive. So all three numbers here are going to be positive, so your product, the product and the quotient is going to be positive. Now if x was, you could test this by using just say x equals 3, of course. If x equals 3, you've got 7 here, 1 here, and 12 here. 7 times 1 is 7. Divide that by 12, you get 7 twelfths, a little less than 1. That's positive, and that's all you got to know, because the function can't change sign to the right of this point. Between -4 and 2, well, we can pick any number between -4 and 2 if we want to. We can pick 0, and we would get 4 times -2 over 9. That's -8 over 9. Okay? That's negative. So we know that the function is to the right of 2, it's a positive times a positive over a positive, which is positive. On this side of, or between -4 and -2, we know that it's going to be a positive times a negative over a positive, which is negative, so the graph's going to be below the axis here. And then, probably should have labeled that above the axis, but too late. Okay? And then between -4 and -9, we could pick a sample point, or we could reason it out. Just take -5. -5 and 4 is -1. -5, -2 is -7. That's a negative and a negative. And -5 plus 9 is positive. Well, we see that we have a negative times a negative over a positive, which is positive between these points. And then on this side, you can check it out yourself. You're going to have a negative times a negative over a negative, and that's going to be negative. So the graph's going to go down here. Okay. Now we want to draw the graph. How are we going to do that? Well, it's negative here. It starts out close to this line. Probably not that close when we're here, but we get way down here, it's going to be close to the line. So it's going to come along probably close to the line, but it's going to have to turn around and approach this negative asymptote. Because again, as x gets close to negative 9, x minus 9 gets really tiny. So dividing by x plus 9 is going to get really big. So we're going to have that. It's going to be big negative, but it's going to be an asymptote. Okay? Then it goes positive. Now again, if we're close to negative 9, we've got something really big, then it's got to be positive here. So it's going to have to come down to an asymptote here somehow. I'm not going to continue that until I see where it's going. But where it's going is it's going toward negative 4. Got negative 4 in the x-axis, point negative 4 is 0. Okay, so it's got to hit this point, and then it's got to come back and hit this point. So it's going to have to come down here, dip down some, and come back up. So let's see if we can make it do that at least halfway gracefully. Okay. Now what does it have to do? It has to approach this line. So it's going to come up like so. At some point it'll probably have a point of inflection. Excuse me, you can learn about that in calculus. A little bit hoarse today, it's allergy season. Hopefully not coronavirus. But anyhow, there we have it. And I don't have any symptoms except a little bit of hoarseness. So not worried about coronavirus. I won't cough in your direction though. I'm pretty isolated here, and that's the first time I've coughed today. The talking kind of has me hoarse. So anyhow, okay. So here we have it, and there is the graph of this function. And for homework, I'm going to give you numbers based on your name and ask you to do the same thing.